Good day, guys. My name is Isaac Ayobami Ogunjimi. Uh, Today, I'll be taking you through another project I just recently worked on. Basically, the project is to determine the number of optimum clusters using the Irish dataset. Why is this project very important? It's because in most cases, we might be faced with a situation whereby we are not given the labels of our data sets and we need to run a prediction analysis, or we are trying to do a labeling of our data set. So to start with, we are going to launch our Jupyter notebook from the Anaconda command prompt, which I already did. Then after launching the Jupyter notebook, uh, I loaded the notebook from my browser. What we are going to be looking at in the course of this project are, firstly, we are going to be importing all the necessary data sets, after which we are going to load the data sets into our Jupyter lab. The data set has already been downloaded on my local drive. We have also attached a link to the notebook where you can also get the data set. Then after that, we are going to carry out some data exploratory analysis, after which we are going to build our K-means model, which is what we'll be using for the clustering. Then after we must have done that, we are going to visually inspect the number of optimal clusters using K-means inertial attributes, after which we are going to draw our conclusion on the number of optimal clusters that we can get from the Irish dataset using K-means. So the libraries we will be working with includes pandas, which we have imported as PD. We are also going to be importing NumPy as MP. Both pandas and NumPy, basically, we are going to be using them for descriptive analysis uh, of the data sets, while we are going to be using pandas in loading our data sets into the Jupyter lab. Then we are going to use the Seaborn, which we imported as SNS, and the matplotlab.pyplot, which we imported as PLT, to carry out a visual analysis on our data set. Then we're also going to make use of the sklen cluster, where we imported k-means from, to also use that to determine the optimum number of clusters in our data set. Then moving forward, in the second cell, we loaded the data set into pandas and we attributed a name to the data set, which is df. We see that the data set consists of four independent variables, or four input variables, and one target variable. And the four independent variables are the separ length, which is in cm. We have the separ width, which is also in cm. Then we have the petal length, which is also in cm, and the petal width, which is also in cm. Then we have the spec, which consists of our target variable. Then we also run uh, a particular function on the data set, which is the describe. And what the describe does basically is to give us a descriptive analysis of our data. We can now look at the number of rows that we have in our data set, which is stored in the count. Then we can look at the mean of each column. We can also look at the standard deviation of each column and the minimum value in each column, the 25 percentile in each column, and the 50 percentile in each column, the 75 percentile in each column, and the maximum in each column. So basically, looking at the standard deviation of each of our input variable, we can see that, for instance, the separ length has a standard deviation of 0.828066, and we see that the sepal width has a standard deviation of 0.433594, and our petal length has a standard deviation of 1.764420, and our petal width has a standard deviation of 0.763164. So obviously we can draw a conclusion from this that given the low standard deviation, that there is a possibility that our input variable is a normal distributed variable. That's one of the conclusions we can draw from this. And by the time we look at the mean value and the median, which is also the 50 percentile, you see that they are also in a close range. So confirms that our input variable is normally distributed. Then aside that, we also run the description on the target variable, and we see that in the description we have three unique data points, uh, and the one that has the highest frequency is the Irish Virginica, uh, which has which appears 50 times out of the 150 count that we have. Then I also run in cell 5 a data.info, which tells us the data type columns, then the number of counts in each column. And from this, we can judge that given the number of counts, which is also 150, by the time we look at the total entry, we have 150 entry. And for each non-null count, we also have 150 non-null for all of the data entry, all of the columns, which shows that we do not have any missing value in our data set. Then we look at the data type, we see that for our input variable, we see that they are all float data type, which means they are decimal in nature. Aside for the species, which is an object, and normally Panda usually represents string as object, so which means what we have there is a string. Then by the time we proceed, I've also created a plot to also confirm our earlier uh, position, that all our input variable are normally distributed. And the plot also confirms that by the time we look at the sepal length, by the time we look at it, we see that we have an approximately distributed curve. We look at the sepal width, the same thing. Then we look at the petal length, the same thing. Then the petal width, also the same thing. Then after that, in cell 7, I carry out a pair plot on each of the input variables. And by the time we compare the sepal length and the petal width, we see that there is a clear division between each of the species that we have, except for the Irish versicolor, which is in red, and the Irish green, where there is a mix up there. Then by the time we look at the sepal length and the petal length, we also see that there is a clear division. And we look at the sepal length and the petal width, there is also a clear division, which means that our model should not have a problem in determining the number of best clusters that we can divide the data set into, which is the main target of the project. Then given this, since basically what we are going to be working with is the input variable, so which means that we have to store our input variable separately, and which is what I did in cell 8, and I use the variable name here to store the data of the input variable. Then in cell 9, I try and create a range for our number of clusters, which is ranging from 1 to 9. Then for each of these range or clusters, I try to determine what will be the k initial for each of these variable clusters. Then after determining that, I did a plot of the k-bits initial, which was computed here, and the number of clusters, which is what we also compute as our range here. And we could see that in the graph that we've just plotted visually, we can conclude that from this graph, the number of clusters, which is the point about which our k-bits initial began to become negligible, which is at this point, we see that our k-bits initial began to slope down very well to a negligible point from where our n will be equals to 3. So from there we can conclude that the optimal number of clusters that we can have on our Irish data set will be 3.